That is done. Okay. Now we will move on to the theory of forced oscillations. So theory of forced oscillations will come from here. Okay. So before that, so different types of damping are covered. Now we will move on to forced vibrations. Okay. Before that, to just give you an idea. Okay. So let us consider, for example, in a park. So there is a swing. So children will be very much excited to play on that swing. Correct. So when they swing by themselves, what will happen? After roughly some 2 or 3 oscillations, the swing is going to come to rest. If it comes to rest, what happens? The children don't enjoy. Therefore, what is required? They should be in constant motion inside the swing. For that to happen, someone should be pushing the swing externally at constant intervals of time. Then only the amplitude of oscillation or amplitude of vibration of the spring will be maintained, and the swing will be maintained at a constant motion. Okay. So applying such an external force, we call it as forced vibrations. Okay. For example, can all of you see here in this video? In this video, look here. Yeah. Okay, can you see here? So here, incidentally, two.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct.
Yeah. So in this video, you will see that two children are in. So they are set into oscillation inside a spring, inside a swing. Okay. Now the thing is, if the swing is not pushed constantly, what will happen? The amplitude of oscillation of the swing will reduce. Eventually, the swing will come to rest. Okay. Therefore, what does the parent of these kids are doing? Of this kid is doing? He is constantly pushing the two swings so that they are set into motion all the time. Okay. So applying such a periodic force is called as forced vibration or forced oscillation. So therefore, let us play this video. Okay.
Follow through.
Okay, so I think you got an idea. So what is that? In order to set a particle in motion, external force had to be supplied at every constant interval of time. Okay, so therefore, applying such an external periodic force, we call it as what? The study of forced vibrations. Therefore, that is what we are going to study. So I think I don't require this anymore. So we will move on to theory of forced oscillations. So in the case of forced oscillations, what happens? Can you see here? So in forced oscillation, what happens? Okay, I'll walk through it. Okay, so can you see here? So in the case of damped vibrations, the amplitude will decrease with the time exponentially. Why this happens? Because of loss in energy due to the opposing force offered by the medium. That is due to dissipation of energy, and the body will eventually come to rest. On the other hand, if a suitable periodic external force is applied to the body, the decay of amplitude can be compensated or overcome. So the body is set into oscillation as long as the external force is acting on the body. Okay. So what does that mean? In the case of the two children who are playing on the swing, if the father does not push the swing, what will happen? The swing will eventually come to rest. But by pushing the swing at constant intervals, what does the father of the kid ensures? He ensures that the swing is set into oscillation at almost same amplitude throughout. Okay, therefore such a vibrations are called as forced vibrations. Therefore here what we are going to do, so here what we are going to see is, if the body is set into oscillation, there will be three kinds of force that will be acting. One will be the restoring force of the spring. Next is the damping force offered by the medium. And next one is what? The third kind of force is going to be the external periodic force that you are applying to the body. So under the action of these three forces, how does the position vary with the time? That is what we are going to study. So therefore, we will now do what? We will study the theory of forced vibrations. So how do we do it? Again, same thing. Look here. What is the algorithm? Algorithm is the following. So what is that? Step 1, draw the figure. Step 1, draw the figure. Then set the body into oscillation. Then find the resultant force acting on the body. Apply Newton's second law of motion for the resultant force and get a basic differential equation in terms of acceleration. Then if you solve the differential equation, you are going to get how x varies with time. Okay, therefore in all our observation, so what is that? This is the same force, it's the same figure. Okay, which is the figure? The body of mass m is attached to a spring. Okay, so here look here, for example, this is my okay, let me take this stuff. Okay, okay, can you see here the body? So it is the same figure. Okay, so here only thing is you have one more force is going to come into picture, which is that, just 1 minute. Okay, I think now the idea is clear. So here, look here. So same thing. What is that? So here the body, I will take red color. So here what happens? Same thing. So the body of mass m is attached to a spring of spring constant k. Then O is the position of equilibrium. B is one of the instantaneous position. The body is pulled in the downward direction. So if it is left, and if this whole, or if this whole vibration is occurring in a medium, say in water, then we will have what? Then we will have resistive force offered by the medium. So therefore, look here. So what are the forces that are acting? Earlier in damping case, what we had? You had this restoring force offered by the spring. Then you also had resistive force. Apart from this, look here. Now what we are going to do? Now what we are going to do is, you will push this body externally. You will push this body externally by one more force. Okay, so that external push that is given, that external force by the father of the child. Okay, so that is given by what? That in our discussion it is given as F into sine of PT. Okay, so therefore let us move on. What is that? So post vibrations introduction is done. Now look here. Consider a body of mass m attached to a spring of spring constant k, and that is executing vibrations in a damping medium acted by an external periodic force. The external periodic force is given by what? F into sine of Pt, where P is the angular frequency of the external force. Okay, with what frequency does the father push the swing? That frequency is given by what? That is equal to F. And what does F stand for? F stands for the amplitude of the external force. Okay, this is clear. So what we consider is, we consider that the father of the child is pushing the swing at a constant interval of time, and that is we consider to be sinusoidal in nature. Therefore the external force acting on the spring is given by F into sine of Pt. Okay, therefore in our diagram, in our diagram, when the body comes, so 1 minute, yeah. So when the body comes, look here, somewhere here, the father is going to push the, somewhere here, the father is going to push that mass M. Okay, so where does the father push? Somewhere here, he will push in the upward direction. Okay, clear? So in what direction will the father push? Push this mass M, he will push in the upward direction, which is M. Okay, or there is some other external agency which is going to push this object. Therefore, now look here. Now look here. So what is step 1? Draw the figure. What is step 2? Step 2 of our algorithm is find the resultant force acting on the body. Now look here. What are the forces that are acting on this body? The forces that are acting on the body are, look here. One, you have resistive force which is acting upwards. Then you have restoring force which is also acting upwards. Apart from that, if the body is pushed downwards, the external periodic force is pushed in the other direction. Okay, therefore what is the resultant force? Resultant force is the sum of all these three forces. That is what gives rise to this equation here. So what is the resultant force given by? Resultant force is given by, resultant force is equal to, so resultant force is going to be the sum of restoring force, damping force, and the external force. Now what is restoring force given by? Look here. Now what is that expression? Expression is given by resultant force is equal to minus kx into this. I'll take a bigger version. Okay, look here. I think now people can follow what I am telling, because it's the same way of dealing, only it is same as that what we studied in the case of simple harmonic oscillator, free oscillations, and then yesterday we studied damped oscillation. Only thing is there is one additional term that has come here. Okay, only this is the additional term, otherwise rest of all is the same. Okay, therefore now let us move on. What is the resultant force given by? Resultant force is, so restoring force is given by Hooke's law, it is minus kx. Then what is damping force given by? Damping force is given by, it is proportional to velocity, therefore that will be equal to what? Minus r into dx by dt. Okay, I gave an example. If you are moving in a bus, the breeze with, the force with which the breeze will enter the bus will be proportional to speed of the bus, therefore damping force will be equal to minus r into dx by dt. Then what kind of the external force is applied on the mass that is attached to the spring? That is periodic force, which is given by F into sine of Pt. Okay, once again I'll repeat. So what is that? Once again I'll repeat. Okay, so what is that? Look here. What is the speed with which the father is going to push the swing? It is given by F into sine of Pt. That's all. External force is F into sine of Pt, where P is the frequency with which the external force is applied on the vibrating system. F is the amplitude. Okay. Damping force is given by minus r into dx by dt. Restoring force is given by minus kx into dx by dt. Okay. This is clear. So I think I don't require any other stuffs. So we will now focus on only solving the equation, and wherever it is required, I will take the thing fresh. Okay. Now, so what is step 2? Find the resultant force. Resultant force is done. What is the resultant force? It is the sum of three components. They are given. Next, what is step 3? Apply Newton's second law of motion for the resultant force. So look here, by Newton's second law, what is resultant force given by? By Newton's second law, the resultant force is given by m into d square x into d of t square. So therefore, what is the resultant force as per Newton's second law of motion given by? It is given by resultant force is equal to mass into acceleration. Next, what you have to do? All you have to do is put this value of resultant force from 2 in equation 1. Okay, put this value of resultant force from 2 in equation 1. Then what will happen? This left hand side is going to be m into d square x by d of t square. Okay, that's what precisely happens here. So from equation 1 and 2, equation 2 can be written as, so from equation 2, equation 1 can be written as, all you are doing is replace resultant force by m into d square x by d of t square. Therefore, what we are going to get is the following. Okay, then what we are going to get, so from equation 1 and 2, equation 2 can be written as, it can be written as what? It will be equal to m into d square x by d of t square is equal to this whole thing. Okay, this whole thing. Okay, this is clear to all. Okay, this is clear to you all. Okay, next what I will do, look here, I'll use say red color. Next what I will do, just shift all these terms. Look here, minus kx, shift it on the left side, it will become plus kx. Likewise, minus r into dx by dt, shift it on the other side, it will become plus r into dx by dt. Don't do anything with respect to this term. Don't do anything with respect to this f into sine of pt. Okay, so if I make this shift, what I'm going to get, the resultant equation is going to be this. So if you shift those terms on the left side, what is the equation I'm going to get? M into, can you see here, it is going to be m into, let me bring it here, write it here, yeah, I don't want this. So what is that going to be? M into d square x by d of t square plus r into dx by dt plus kx equal to f into sine of pt. Okay, so I'll remove all unnecessary stuffs. Okay, so if we shift all these terms on the other side, what we are going to get? What we are going to get is m into d square x by d of t square plus r into velocity plus kx is equal to external force applied, and external force is given by f into sine of pt. Okay, this completes step 3. What is step 3? Apply Newton's second law of motion and get a basic differential equation in terms of acceleration. Now in terms of acceleration, if you want, all I have to do is divide force by mass. Okay, therefore next step what happens? Look here, next step, dividing throughout by m, so we get d square x by d of t square plus r into d, r by m into dx by dt plus k by m into x equal to f into sine of pt, which we call it as equation 3. Okay, how does that come? Look here, I'll paste it here. Look here, suppose I choose red color. Yes, look here, if I divide it by m, what I'll get? If I divide it by m, so divided by m, this term is going to be r by m, which is this, then this term is going to be k by m, which is this, and left hand side is going to be f by m. Okay, there is f by m here, it is just missed in my notes. Okay, it's going to be f by m. Okay, clear? This is clear to you all? So there is an m here. Okay, f by m is there, it is just missed in my notes, but I have taken care in the subsequent this. Next what I will do, I'll call this as equation 3. This is our equation 3. So I have to solve it. So I have to solve it and find how x depends on time. So for that, what I'm going to do, same thing, just like how we did in the case of damped harmonic oscillator, we'll introduce two more new variables. Same thing, omega square and 2b. What is that? Look here. So next what we are going to do, so let r by m be equal to 2b and omega square equal to k by m. Okay, what does that mean? What does that mean is, look here, let me take this, look here, this is my equation 3 here. These are my two new terms. Okay, can you see here? Same thing, just what happened in the previous class. Okay, look here, r by m is called as 2b. What is that? It has something to do with damping coefficient. And what is k by m? K by m is nothing but natural frequency of vibration, which is omega square. Okay, and of course you have F by M below. Okay, there is F by M here. Okay, now look here, from equation 4 and equation 5, equation 3 can be written as what? That is what gives rise to this. So what you are going to get, look here, let me collect it and then put everything, interpret everything in the single frame. Okay, so this is my resulting equation. Okay, now all of you, can you see? Yeah, look here, from equation 4 and 5, equation 3 can be written as, this is equation 3. Okay, what is that given by? Look here, you have d square x by d of t square, which is this. Then r by m is 2b, therefore you have 2b into dx by dt. Then k by m is omega square, therefore you are having omega square into x. This is equal to the quantity on the right side, which is f by m into sine of pt. This much is clear. So all of you are with me? Or people with me?
Sir.
So people are with me? So this much is clear, right? Okay. Okay. Next, look here. What is the next goal? So this much is clear. Therefore, up to equation 6 is clear. Okay. So therefore, here also what I'll do, I'll retain only 6. I'll just retain only 6. Okay. So now look here. So this is the equation that we want to solve. Okay. Right. Now look here. What is the right hand side? A sine function. What are left hand side? Dx by dt is something. Then you have dx by dt and you have x. Okay. Can you see here? Someone today came just now. Okay. See, all of you have heard of this thing. All of you have heard of there is virus in computers. Okay, virus and an antivirus software. Correct? No, all of you have heard. So there are several people working to produce new set of virus and also to give you a new antivirus, which is a solution for that virus. So what are virus in computer terminology? I'm not talking about biology. Okay, in computer terminology, what are viruses for a computer mean? It is those malicious program or pseudo programs which are either going to destroy your computer, or it is going to steal or rob or collect lot of very valuable information that are related to you. Okay, so therefore now generally when a new virus comes, you would have also seen that in the same, either in the same day evening or the very next day morning, antivirus will come in the antivirus, I mean the solution will be solution to cure that virus or to eliminate that malicious program will be injected separately. So it comes almost within a span of 1 or 2 days. Have you observed this? Virus comes on one hand, new malicious program comes on one hand, and a cure for it, that is antivirus, will also come on the very next 1 or 2 days. How is that? Is it possible? See, for coronavirus to find vaccination, we almost took 1.5 years. But here, what do you see? It happens almost on the same day. You understood what I'm telling? Got my point? How come someone introduced a new malicious program to destroy computers in the world, and how come a cure exists the very next day or within 2 days span? Okay, that is why there is a saying in Hindi. What is that? जो दिमाग एक इंसान की भलाई सोच सकती है, वही दिमाग उसकी बर्बादी भी चाह सकती है. Okay, what does that mean is solution and the problem and solution, they coexist in the same place. Okay, it's the same person who generate a new virus and they will also generate a cure for it. Okay, generally hackers will in their PC they will have around 7 or 8 different operating system. Even if one of their operating system is corrupted, they can reboot their system using a different operating system and they can set right the things. So therefore, what is the moral of the story? If you have a problem, there are high chances that solution to the problem will lie there only. The solution to the problem lies in the problem itself. Okay, what does that mean? Can you see here? What does that mean? So what does it summarizes to? So I want to solve this differential equation. My solution will depend on the nature of my external force. External force is sinusoidal in nature. Therefore, the solution to the problem lies in the problem itself. So what does that mean? The solution of the above equation is of the form. It also have to be a trigonometric function. Therefore, the solution of that problem, solution to equation 6, that is how x depends on t. How is that given by? That should also be a trigonometric function. Therefore, the solution to the problem lies in the problem itself. Okay. Therefore, solution also has to be trigonometric in nature. Therefore, what is the solution of the equation given by? X of t is equal to a into sine of pt minus alpha. Let me call this as equation 7. Okay. So I don't want this from the file. Go to paint. Okay. Now can you see here? This is equation 6. This is equation 7. So the solution to my problem lies in the problem itself. Correct? Therefore, the solution of equation 6 is given by x of t is equal to a into sine of pt minus alpha. Means the solution depends on the nature of the frequency of the external force, that is p. Okay, so solution to the problem lies in the problem itself. So x of t is equal to a into sine of pt minus alpha, where a and alpha, these are the new constants that have to be determined based on certain initial condition. Okay, what is a? A is the amplitude of the resultant motion, alpha is the phase lag. Okay, so again the same things. What are those? Look here. Okay, again the same thing, same technique of solving it. What is that? Look here. I know what is x as per equation 7. I'll find dx by dt by differentiating equation 7. Then find d square x by d of t square by differentiating equation 7 twice with respect to x. Plug in those values in equation 6. And if we simplify it further, we are going to get the solution. Therefore, what does that mean? Look here. Therefore, this is done. Up to this point is clear. Up to the solution to our problem is given by x of t is equal to a into sine of pt minus alpha. Okay. So where a and alpha are the unknowns to be found based on some initial conditions. Okay. A refers to amplitude and alpha refers to the phase of the simple harmonic motion. Now, how do I find dx by dt? Differentiate with respect to t. You're going to get dx by dt is equal to a into cos of pt minus alpha. Okay, look here. Copy this. So if I differentiate equation 7, if you differentiate equation 7, what is velocity given by? Velocity is dx by dt is equal to ap into cos of pt minus alpha. I think it is clear. D by dt of sine theta is cos theta, and if you differentiate pt minus alpha with respect to t, p will come out. Therefore, that p is here. Okay, so it's going to be what? ap into cos of pt minus alpha. Okay, next, if I differentiate 7 again with respect to time, if I differentiate equation 8 with respect to time, you are going to get acceleration. So what is acceleration given by? Look here, I will extract this. Acceleration is given by d square x by d of t square is equal to, so acceleration is given by this. Okay, I will put it here. For example, I'll put it here. Yes, if I put it here. Okay, what is acceleration given by? Acceleration is given by, so look here, d by dt of, what is d by dt of cos theta? Yeah, d by dt of cos pt minus alpha is minus sin pt minus alpha. And so what we are going to get, again p is going to come out, therefore it's going to be minus a p square to sine of pt minus alpha, which I'll call it as equation 9. Now what I have to do, substitute the values of x, dx by dt and d square x by d of t square from 7, 8, from 7, from equation 8, from equation 9, in equation 6. Okay, if we do that, what we are going to get, look here. So what we are going to get is, it's going to be a big expression. Okay, so what is that going to be? It's going to be this. So look here, I will eliminate all these. Let me have a fresh file. Yes, so look here, my equation 6 is this. This is my equation 6. Okay, this if I put it here. Next, this is my resultant equation. My solution is x of t is equal to a into sine of pt minus alpha. That is this. Okay, then if you find velocity, acceleration, and if you put it in equation 6, what we are going to get, the resultant equation is going to be this. Okay, I think I'll just take the text as well. The resultant equation is given by, okay, call this as equation 8. Okay, this will be the resultant equation. All of you can see that there are three different chats. Can you see 3 different WhatsApp messages? Can you see here? 6, 7, 8, 6, 7 and 9. Okay, so look here. So from equation 7, 8 and 9, equation 6 can be written as what? It can be written as minus ap. It can be written as minus ap square into sine of pt minus alpha plus 2b ap into cos of pt minus alpha plus omega square a into sine of pt minus alpha. This is equal to f by m into sine of pt. Okay, I already told my m lies in my denominator. Okay, next look here. What can we do further? What can we do further? Now look here, the right hand side of the equation 7 can be written as, can you observe here? All of you, can you observe here? Look here, right hand side of the above equation can be written as, okay, can you see here? For example, I'll copy this. So, okay. This is my equation 9. Okay, can you see here? Look here. I'll use say red color. Yeah. Can you see here? On the left hand side, all the terms are with pt minus alpha, and pt minus alpha. Here you have only pt, correct? No, here you have only pt. Okay, what does that mean is, on the left hand side, all people are wearing mask. On the right hand side, the person is not wearing mask. Therefore, what we will do, we'll also make the quantity on the right hand side to be same as that of this. Make him also to wear mask. What does that mean? Look here. What does that mean? Look here. So for PT, I'll just add plus alpha and minus alpha, and I'll group it in such a way that pt minus alpha is grouped together, which forms on the same footing as what you see in the left hand side in all the trigonometric terms. Okay, therefore what happens? So the right hand side of the above equation, can you see here? Right hand side of the above equation can be written as f by m into sine of pt minus alpha plus alpha. So that will give rise to this. Okay, next look here. If you expand, if I expand the right hand side, if I expand this right hand side, sine of a plus b is what? Sine a cos b. So therefore, if you expand the right hand side of equation 9, what we are going to get? Look here, I'll just write it here. If I expand the right hand side of equation 9, what you are going to get? Before that, look here, I'll take this here. Okay, okay, can you see here? If I expand my right hand side here, sine a, sine of a plus b, what is the formula in trigonometry? It is sine a cos b plus cos a sine b. So therefore look here, I will call this as a and I'll call this as b. So if you expand sine of a plus b, what you are going to get? F by m into sine of pt minus alpha cos alpha, sine a cos b plus this into cos a sine b. Okay, is that clear? So if I expand the trigonometric term, what you're going to get is this equation, f by m into sine of pt minus alpha into cos alpha plus f by m into cos of pt minus alpha into sine alpha. That's, and left hand side is same throughout. Left hand side is just same throughout. Therefore left hand side now will be equal to this right hand side, and that's what is just given in this above equation. Okay, so therefore now look here. So I'll just take this term now. Understand what I'm telling? Look here, don't want other things. Yeah. Okay, now this is our basic equation. Okay, next what we do? By equating the coefficient of sine of pt minus alpha on both sides, we get this equation. Okay. Okay, look here, what does this mean? What does this mean is, look here, by equating the coefficient of sine of pt minus alpha on both sides in the above equation. Okay, what do you get? Look here, where are the terms you have sine of pt minus alpha in the, you look here, you have here, look here, sine of pt minus alpha is here, then we have sine of pt minus alpha here. This is cos of pt minus alpha, therefore that will not come into picture. Okay, on the right hand side, where do you have sine of pt minus alpha? It is here. Therefore what we get, if you equate the coefficients of sine of pt minus alpha on both sides, the first term you're going to get ap square minus ap square, which is this. Then you have a omega square is this, and on the right hand side what you are going to get? F by m cos alpha, f by m cos alpha. That's precisely is this. Okay, that's precisely is this. This is clear. That gives rise to equation 10. Okay, next, similarly, by equating the coefficient of cos of pt minus alpha on both sides, what you are going to get? You're going to get a similar equation, which is given by 2b into, which is given by 2b into Okay, it's given by 2b into sine of 2b AP equal to sine of sine alpha into f by m. Okay, that is this. So is this clear? That is equation 12 and sorry, equation 10 and equation 11 is this. Now look here, what is the goal? Goal is to find amplitude and then the phase alpha. So how do I find amplitude? All you have to do is simply square and add the equation. If you square and add the equation, you're going to get this equation, that is amplitude will be equal to f by m into f by m divided by square root of 4b square p square plus omega square minus p square whole square. So how do I get this? Okay, understand what I'm telling. Okay, look here, one simple technique we have. I'll eliminate all the key equations. Look here. Now what does it summarizes to? Just focusing only on these two equations. Other one is this equation 11. This equation 11. Okay. Call this as equation 11, which is this. Okay. Our goal is by using these equations 10 and 11, I have to find A, then you have to find alpha. Okay. So how do you do? Simple. Don't get confused. Look here. I'll just show you a simple technique. Understand that. So when that we do it here, we get that final expression. What does that mean? Look here. Let me go to a doc file. See, for example, if I take the parametric representation of a circle. Okay. For example, it's given by say x of t. X of x is equal to a cos theta. Okay, then you have y is equal to a into sine theta. Okay, so let me call this as, for example, the equation. For example, equation 1000, and this I'll call it as equation 1001. Okay, now look here, from this equation, what is cos theta? X by a. Okay, now if I from these two equations, if I have to get a equation where you can eliminate theta, then all we have to do is make use of the trigonometric identity. What is that given by? Cos square theta plus sine square theta equal to 1. Correct? No, this trigonometric identity we have from mathematics, right? It's a consequence of Pythagoras theorem, right? Therefore, what you do? Find cos theta from 1000, equation 1000. Find sine theta from equation 1001. Then plug in into this equation. Therefore, if you square and add, what you're going to get? You're going to get an equation in terms of cos square theta plus sine square theta equal to 1, where you can beautifully apply this identity. The same thing is what done here. Okay, look here. From here, what you see, if you square and add, you will have f by m, f square by m square cos square alpha. Then you will have f square by m square sine square alpha. So what is cos square alpha plus sine square alpha? That will be 1. So therefore, that will give rise to this final expression. Okay, that will give rise to this final expression. So you will get a is equal to, which is this equation 1. Okay. So how do you find a? By simply squaring and adding equation 10 and 11, then the alpha gets eliminated and you will get an expression purely in terms of amplitude, which is going to be this equation 12. Okay, can you see here? That will be the expression for amplitude. Okay, what is the expression for amplitude? Expression for amplitude is this. Can you see here? Okay, I'm trying to highlight now. Okay, what is equation 6? Equation 6 is, sorry, equation 12 is this. Here. Okay, can you see here? This is equation 6, sorry, equation 12, the expression for amplitude. Okay, next, how do you find the expression for alpha? All you have to do is look here. Sin theta by cos theta will give you tan theta. So divide one equation by the other, you'll get an expression for tan alpha. So therefore, what is the expression for tan alpha given by? Look here. So what is the expression for phase of forced vibration given by? The expression for forced vibration is given by dividing equation 11 by equation 10. Sin alpha by cos alpha will give you tan alpha. So therefore, tan alpha is going to be this. Okay, tan alpha is going to be this, or alpha is equal to tan inverse of this quantity. So this is how the phase and the amplitude of the phase and amplitude of the forced vibration deals. Okay, so I'll stop here. In the next class, we will see how the amplitude and phase will vary with the frequency of the applied force, and then we'll discuss the concept of resonance. Okay, so or anyone having any doubts? See, little bit there is more mathematics involved, particularly in equation 10 and 11. So therefore, you work it out. It will come. Okay. If people have any doubts, you kindly ask me. I will address it in the tutorial session.